We are now. Thank you.
Thank you. All right. So as I mentioned, we're going to be talking about consuming APIs. That means we're going to be interacting with the client, not the server side. And the GitHub API that we will be using to learn how to work with them is the GitHub API. So the first thing that we're going to do is create a personal access token. This is a token that we can use in order to authenticate ourselves to GitHub instead of using our account credentials. And it also allows for fine-tuning the permissions. So we're going to generate a new token. Here we can say something like DSPG. This is just a note for you to remember what the token is for. Then we have to define a scope. You can read more about the scopes here. The scope basically means what permissions can an application using that token can actually do. So it's limiting what the functionality and what access to information it has. So for example, if it has no scope, it will only access public information. That includes public users, profile info that's public, etc. If we wanted to have information or permission, let's say, to write, basically change membership of an organization that we administer, then we would have to select either write org or admin org, which admin org basically just gives you the two permissions together. Same for user. We want to allow, let's say some application wants to have access to your email account. So maybe they can read the user email, but they can't modify it. Basically, they are executing commands to GitHub or interacting with GitHub on your behalf. So it basically, it's a way of allowing others to have some permissions regarding your account. For our purposes, we'll only need, I want to say public repo. I think I might have mentioned just full control private repos, but I believe we only need public repo and read org. We might need that. Let's do read user email. We're not going to be modifying anything, so it's just reading information that's not sensitive. So basically information that's should we change from repo to repo only? It really doesn't matter because we're not going to be inviting people to our repos. If you can, this is an approximation, just the ones that I believe we might use. But you can always update the scope of your tokens. All right. So I'm just going to go ahead and generate that token. And you will get something like this. Here I'm recording it and showing it to y'all. So I'm just going to delete that token. You shouldn't delete it because that's the token that we're going to be using. So I have different ones for today. I will be using this one, which is read org, read on user. I can just go ahead and delete that one. And if I wanted to change the scope of that one, which is the one that I did yesterday, I can just go ahead and uncheck and change to public repo, read org, and let's say change those there. So you can always update the token. I have updated the token, and now it's with the permissions that I care about. Any questions so far on how tokens are used, generated, managed, what they're useful for? Okay. All right. Let's do our first yes or no. If everyone is up to date, they have a token that they can use for today's training. 1, 2, 3, 4, 5. Perfect. Seems like people are, everyone has access to a personal access token. Perfect. So what we'll do today is interact with GitHub API. API. Let's see if I can see that. Let's do to help. Do API. And what I want is the GitHub developer. There we go. And we have two versions here. Docs, REST API is the first one that we're going to talk. So I'm just going to go ahead and put that in chat. So right now we're going to be looking at the developer.github.com version 3, and this is a REST API. So REST API, go to Wikipedia. It stands for Representational State Transfer. So sometimes you will see it REST or RESTful API. And the idea here is that people are going to use HTTP or curl, some way of working through the internet. And let's see, here we go, using some method. So these are the most common methods. I believe these are not exhaustive, but they might be, yeah. So for example, when we do GET request, that means that we're querying some data. If we're doing POST, that usually means that we are creating some new resource, basically some data. If we do PUT, basically that's for updating, usually. Delete that resource, and then I don't recall any API that has patch, but it's available. So these are like some verbs in HTTP protocol that, based on a URL, you can interact with it with one of those methods. And usually an API will change their behavior depending on the method and the URL. For GET, usually you give all the information either through the URL, like the resource that you're hitting in the server, or it takes information as well in the header. So as we mentioned before, I believe yesterday, yes. When we send a request, we're sending the URL is the address in the server where we're hitting. And the header has some extra information, which is similar to the header in HTTP documents. I mean, in HTML documents. When we use POST, that allows us to send some data as well. So we'll be sending some document or some data, usually through bits or a JSON file that gets converted into bits and then it's transferred to the server. So that's kind of like the difference. And usually you will be using GET and sometimes POST for REST APIs. For GraphQL APIs, which we'll talk later, it's always POST. So there isn't a difference between GET, PUT, patch, delete, no. They all use the same method. Okay. Any questions so far? No? Okay. So REST APIs are versioned. That means that when you're hitting an API that is REST, you basically have to pass a version of that schema. If you don't pass one, usually it will default to the current version of the API. So for GitHub, it's version 3. But there are some places that you can basically give a hint of what version you're using, okay? So basically it's here. By default, every request goes here, receive the version 3 of the REST API. And the way, or the reason why we version APIs is if we make a change, we don't want to break everyone else's code. So we version that because it doesn't allow for different behavior to be deprecated or changed. And so we're now gonna talk about the first header argument. So as I mentioned, headers are request. And usually a pretty common one is the SEP header. The SEP header basically tells you what kind of, or format of the information you want to access. So for example, some APIs, like the COVID project that we talked about yesterday, you can define what format you want to get back by adding .json or .csv. And depending on the URL, that's how it gets returned, or the format, the response. Most APIs, what they do is they pass it as a SEP header. So here, what I'd say is I want the application to give me the result based on the GitHub version 3 API, and I want it in JSON format. And JSON is the JavaScript object notation that we talked about yesterday. So what's the schema of what you're getting back? When you're making that request, you will get a response like this. Oh, here we go. It tells you the status code, basically 200 is okay, as we mentioned before yesterday. Gives you the server, other information. And here, it actually tells you some information about the status of your account regarding the API. So the X rate limit means what is the limit for consuming the API in some given amount of time. Here is per hour. So in the last 60 minutes, the last hour, how many, say, costs have you incurred using the API? The rate limit means how much you actually have remaining. So at this point, the limit is 5,000, and you currently have 4,987 remaining. And the X rate limit reset means when does it reset, so you can get more, basically refresh your account of remaining. Does that make sense? Yes. Do use the chat or interrupt me if there are questions. So you'll see that the limit reset, it's not a date time, it's just a number. So that's a timestamp. And the timestamp basically means it's the number of seconds or milliseconds, depending on the API. Most APIs use seconds. Twitter, for example, uses milliseconds. So how many seconds from some epoch or some time has passed? And most of the time, and something that can make it pretty hard for people to interact with the API, everything should be in the UTC time zone, unless specified otherwise. So time zones are extremely important when you're working with APIs. Just keep that in mind. I'll eventually show some examples of why that matters. All right. So the next step is authentication. Some APIs, as the one that we previewed yesterday, don't need to authenticate. Anyone can just go ahead and download that file or make that query. Most APIs, however, require some authentication. For example, if you're using the Twitter API, you basically have to first submit an application, specify which government agencies might have access to the data, and specify your credentials, give basically a full application in order to get access to using the API. Oh, wait, I got something here. So the timestamp for the rate limit is the number of seconds, or is it a date? I'm confused. It is a date time, and it's expressed in the number of seconds since the epoch. And I believe this one is using the Linux epoch. So it's a number of seconds since 1970, January 1st at 0000 Zulu time, which is UTC, or the uniform time zone, basically. Does that answer your question? And we'll go over an example of how to reinterpret that. So, perfect. So there are multiple ways to authenticate. Sometimes you can just pass a username, and then it will prompt you to input your password. The better way is using the tokens, and that's what we'll be using. Just a little, yeah, so GitHub recommends using the tokens. Sometimes APIs allow you to pass the password as part of the URL. That's usually in older APIs, and most of the newer APIs actually pass it as a header. Okay. So in this case, if you have a token, you would pass the header authentication authorization, token space or colon space, token space, and then your token. And that's how you authenticate against the API. Okay. Whenever you make a request, you should be able to handle and respect what you're getting back, especially when it comes to errors. So for example, if I pass the wrong credentials, I will get a status code 401, unauthorized, and it will give me a message about credentials, and then it will give me the documentation to where I can look up what's going on. It's important that when you're using APIs and all that, you respect those. So for example, if you were to just query the API really fast, a bunch of times, eventually that might trigger an abuse. And if it triggers an abuse, you might get the 403 forbidden, and it might give you, or actually this one is for forbidden, as in you have been trying a bunch of different passwords. Please don't do that. And if you keep doing that, it will lock you out for some time. Okay, does that make sense? It's pretty similar to interacting with the browser. If you're doing it many times, you will get a different status code that will be rate limit abuse, or yeah. And then it might give you in the message or as part of the header, please retry 2 minutes from now. And then you should use that value to wait and then do it at that time. So whenever you're getting status code or some extra information, respect that. For example, you might be hitting an address that actually moved, and it will redirect you. So that's basically telling you that you should update your code and use the updated address, for example. So far, so good? Okay. So for doing a query, you likely will have a base URL, which will be this part here. The base URL stays the same. And then what you have afterwards, this here, up to here, well, in this case, up to here. That repos, let me make it a little bigger. That's an endpoint. An endpoint is basically one part of the API that has been implemented for some purpose. So if you want to query or get information about users, you will be using the user's endpoint. If you're using it for repos, it would be the repos endpoint. For example, if I'm working with weather data, and there is the global historical climate weather stations. And then there is another one that gives me current values about the level of the sea. So information that's separate or has been organized differently will use different endpoints. Okay. After you connect to that endpoint, so you have the base URL, the endpoint, and then everything that goes after are arguments to the endpoint. Some take some arguments, others do not. For example, the repos endpoint takes arguments owner and repo. So that means that you're using this log. So if I go to some repository, you will have the owner and then the repo name. So basically, in order to identify a repository, these are the two arguments that it will take, the owner and name. So we have base URL, endpoint, arguments, After here, I have identified a repository. After I have identified a repository, then I go to a different endpoint, which is the issues. So now I am crawling the data structure, the schema, to saying, I first want to identify repository up to here. And then I'm going to look at the issues information of that repository. What comes after, usually when it's query or you're passing some parameters, it will have the interrogation mark, question mark, and then value key values. So you will have a parameter or a value that you want to select, and then the value. So here what's saying is, I want to get from GitHub, from the BMG red carpet repository, the issues, and here I'm filtering to those that are closed. Does that make sense, the syntax? And then, yeah. So here, when they're doing the example, they pass the username, all that. Here, they're passing an extra. I believe this is a header. So they're saying, I want the repositories or the information that's public. And that's for the REST API. It's just knowing how to play and modify these. And we'll go over examples of those. This is what I mentioned about redirects, temporary directions. This is what I mentioned before about HTTP verbs. This is extra information relating to the GitHub API. And one thing that trips a lot of people is when you have many results, you're querying something, let's say, I want to get all the repositories in GitHub. The API will not give you all the results because there are way too many. So what they will do is they'll give you a subset of those. Usually for most of the requests through the GitHub API, the default is 30 items. So you will get the first 30. You can modify that with the per page argument. So if we're doing per page, I'm saying each page should have 100 items. And then I can pass the page number to just paginate. So that means that here I'm going to get the 101st record to the 200th record. Does that make sense how pagination works? Let's see, let's do a yes or no on the, okay, perfect, I see some yeses. Cool. As I mentioned, we always should take care of, let me just clear that, of respecting the rate limits. So here the information, for example, for the federal government, GSA has one uniform API, and you have the same rate limit across like 30 or more different federal government APIs. They use the same authentication, the same method, and the rate limit is across all of them, just as a matter. The census uses a different one. So you always read the documentation because no API is the same. No two APIs. So for those, basically what it's saying is many times you can play with an API without authenticating, and you will have a really low rate limit. That's usually for people to try it out. But if you want to increase that, then you have to authenticate or pay, for example. Some of those might include like Google's reverse geocode. So they provide the service. Sometimes they give you a low rate for free, but if you want to use it more, then you have to pay, or they bill you per usage. So one way that you can get the information of the rate limit without incurring in a cost is through the Let's see where it is. So every request will give you the information, but there is a way that I'll show later on that you can query that information for free. So it doesn't cost anything to just go and tell you, I don't want any data. I just want you to remind me what's my status regarding the how much I can consume. And some endpoints might have different limits. So for example, the search API has a different rate limit than the core API. And the GraphQL API has a different independent cost with the core API, which is the REST API. So if you really wanted to do all or use all three, then you can do that because they run independently. There we go. So here basically it's telling you that in order to get more higher rate limits, you need to authenticate. This is a little bit more about abuse. So for example, some APIs require you that you wait a second or half a second before doing a subsequent query. If you were in the, I believe the symposium or the speaker series, the speaker mentioned about APIs, and when he teaches, they pass the email information of the student in case someone doesn't like that, they can contact them. So I don't recommend passing your email as the user agent, because the user agent initially was supposed to be the technology that you're using, what kind of browser. And that argument then allows you to customize experience based on the technology that you're accessing, the server or the web. GitHub kind of pirates that, and there is the user agent, and that's when you pass your login. So it's a little hacky. It doesn't make sense to have a user agent per se in the original semantic for an API because you're not accessing through the web. But user agents for GitHub is your login, basically. And something that we can practice, not many APIs allow for it, but it's nice to have, is that you can make conditional requests. That means that sometimes you're querying the same element or the same object. You just want to update it. Let's say I want to check whether this user changed their name in their bio. So rather than telling the API, I want to get the name of the person, I can say, give me that if it has changed since this date, since I last queried. And using conditional requests allow you to do that a lot faster. No data is being transferred. It just resolves and tells you, oh yeah, that's what we have. It hasn't changed. Then it just gives you that information. So you don't incur that cost, and the service don't have to transfer all the data. So that's one way that you can use it. For example, you can say, I don't know if this user exists or not. So return some data only if the user exists. If it doesn't exist, then don't give me an error. I don't mind. I just wanted to know whether it existed or not. So here they're saying a little bit about the time zones. Time zones are, I have made these errors so many times that I learned my lesson. Whenever you're sending information, because the server doesn't know what you meant, it will have heuristics that can bite you. So for example, it might interpret the time that you're sending it through the last known user time zone. That happened to me because I was running some code when I was in Virginia, and then I went to Germany for a couple of weeks. I was running my code, and then I was like, wait, this doesn't make sense. Why is the data not what I wanted? It's not what I expected. And the issue was that I was using the time zone, but because I moved, the code was now giving me a different behavior. So just make sure, to the extent that you can, to be explicit about it. either pass it through the header, pass it when you're passing basically the datetime, or the timestamp, add the time zone information directly there. That's the best one. If not, pass it as a header. And the issue is that sometimes some endpoints will default to UTC and others won't. So just because something works on one endpoint doesn't mean that it's going to behave the same across all endpoints. So make sure that you test your code when you're using an API. All right. I think that's pretty good summary. Let's see if I'll just mention this. So right now, there's a mix in functionality between the REST API, the GraphQL API, which is great because sometimes the GraphQL API allows you to do something 1,000 times faster, which is nice. And sometimes that functionality doesn't exist yet in the GraphQL API, so you have to use the REST API. So there's some ways of basically using both at the same time or complementing each other. And one way is you can get a unique identifier, which is called a node ID, using the REST API, and then you can pass that as a unique identifier for the GraphQL. So that's just something to keep in mind. You're using different APIs by the same provider. They might have some code that basically allows you to do some work on one and then transfer it or transfer some of that logic to the other. Any questions so far? Good. Let's see, let's do yeses, because then I will move to examples. Let's do 3 more yeses. 2 more? No, anyone? 1 more? Perfect, okay. So let's do some examples now. Let me share my screen on. Share screen. Visual Studio Code. Learning. Okay. All right. So I'm just gonna run this code here. Let me see if I can make this a little bigger. Zoom in. Is that good for everyone? Yes, you speak out. Okay. So I'm using Julia here. Just a little note on like the packages that I'm using. libpq is just a way to interact with a database. So especially for a Postgres database, that would be our PostgreSQL in R. The time zones package allows you to use time zones. If you want to lubricate, dates is standard library. Diana is a GraphQL API. That would be GraphQL, if I'm not mistaken, in R. HTTP, we have mentioned it before. That would be HTTR, JSON3 for JSON. That would be your typical JSON-like in R. Data frames, it's data frames. Think of it like data tables, for example. Let's see. No, it's not on the training folder yet. Still figuring out what I want you all to practice with. But you have the recording and I will share some of the files. Yes, remind me if I don't, hold me accountable. So some of you have mentioned, okay, so how do we store the data from basically web scraping? You can save it as files or the JSON, or another approach is to save it directly to the database. So here I'm just having a local Postgres database and make a connection there. And we have the example on pretty much we have the code for you to do it through R, but here I'm just verifying that I'm running, let's see. We'll do some exercises. I don't think we're gonna do the Julia ones, but I'll give you some exercises to run in an interactive environment. But you're more than welcome to ask me for the Julia code, yes. So here I'm just running PostgreSQL version 2. It's actually a PostGIS. So I'll go over how I have structured some of the code for a project using the GitHub API. And that one uses GraphQL mostly, but uses the REST API for a little bit. So here I'm defining a constant. I'm documenting that. So basically I'm saying this is the GitHub REST API endpoint. That means this is the base URL. And here, if I do that, make sure that document your code through docstrings. It will just tell you the information. And then I did the same for the GraphQL version 4. The GraphQL version 4 uses api.github.com, and then instead of a version, it uses GraphQL, because GraphQL it's not version at all. You can change the schema without breaking things, so you don't need to version that. Okay, so a question here is what tools or languages I would recommend to interacting with an API. I would say it depends on what you need and what's convenient, right? But let me say a little bit more about that. Some APIs give you the bare bones, and when you want to do a little bit more than that, it's good to have an interface. An interface is a library for some language or whatnot that does a lot of the basic functions in a neat way. So for example, for weather data, there's an API that gives you, say, some variable information about weather zone in one area. But I did a library a few years back where you just pass a zip code and some dates, and it will give you the weather stations 50 miles or the radio from those zip codes that had the data for that there. And it would, I believe it will approximate some values if they were missing and give you some information about the data quality, etc. So APIs are low level. If you have an interface that's useful for you, or if you build one, then that's even better. For example, for the OSS one, we have one that handles the rate limits. So what happens if you're running the code and you hit the limit, then we include there in the logic, oh, you should wait until the reset time. For the GitHub API, we're right now running about 40 different processes at the same time. So we use distributed parallel processing to be faster in our data collection. So that means that we have to handle getting the information through 4 different cores in the same node with different tokens doing different queries, and then aggregating everything into the database. So that's not something that I would use the terminal for or shell for that. Other than that, waiting, parallel processing, other logic of taking that information and put it in a way that's suitable to include in the database. Yes, so that's an example of Tidy Census. Is an interface to the Census API that automates the bare bones core functionality of the Census API and makes it a lot easier to use. So interfaces are great, and if you're starting to program, I would say I encourage everyone to try that as your first project, just because it's kind of neat and easy. It's the same tools and you can apply it. Just read the documentation, get familiar with an API. It's just a few functions. It's basically all the same. You just need to work piece by piece, and then you get a nice product that's useful for others. Okay. So here I'm just making a struct to keep track of the limit for that endpoint, how many I have remaining, and the reset time. And then I have limits for the core, the search endpoint, and the GraphQL because those are separate. I have a struct here that basically what it does is it takes a login and a token, because that's the way I'm going to authenticate myself, and it builds a GraphQL client. We'll go over that, what that means, but basically the client is an object that has all the information that it can go and communicate with the GraphQL endpoint, get back some information. So I'm just gonna go ahead and create a GraphQL personal access token. We're not gonna do GraphQL just yet, but I'm gonna reuse that on the REST API. So what I'm doing here is I am using environmental variables. That means that I'm not putting my credentials in the actual code, because that would be bad in terms of security. And also it would break other people, or it will prevent other people from using my code. So whenever you have credentials or something like that, you want to have it in an environmental variable, and then the code just calls environmental variable. So here, I'm gonna make my first REST API call. Let me just make this a little clearer. So what I'm doing is I'm making an HTTP request using the GET method to that URL. That URL is the REST API base URL, and then the user endpoint. For my header, I'm passing the accept application v3 JSON. The user agent is my login. I can show you all here. For example, that's no Rican. And then for authorization, I'm passing the token. So that's how I authenticate. So let's do this. I'm gonna comment that out. And I'm going to say 1, 2, 3, 4. That's a wrong token. That's not mine. Let's see what happens. Am I missing? Oh, here. All right. And let's see what happens. So I got an error. And the error was a 401 unauthorized. That means I didn't like my credentials. The way to handle that would be to use a try catch and then do something based on that. So I'm gonna try to do that. If there is an error, I'm going to get the error. Let me use call.x. I'm gonna run that. So now I have caught the error, and I know, and now I can interpret the error, what's going on my code. So for example, to error, it's just status. Property name. Oh wait, this is X. So yeah, X does has status. It's 401. So in my code, what I would do is I would put a try, a catch, then look at the code and say, oh, this is what's going on. I should not try it again. I should actually handle and address that and make sure that I have my right credentials. So here, I notice I was using the wrong credentials. Now I can fix that and I can run the query. What I got is an HTTP response. That's 200. That seems all good. Let's just verify that. Yes, that worked. So I know this is the version of the HTTP protocol, and I have my headers. So when I got the information back, I got some information additional to the data. For example, what was the server, when that happened, the content length, the status, etc. For example, this will give me the scope of the method that I'm using to authenticate. If I want to get the actual data, that's just a JSON, and I can just read the data or the body. And let's see what the JSON has. So JSON has the following fields. It has login, an ID, node ID, avatar URL, all the information basically about the user. That would be me. So if I wanted to get my name, I can just get that there. If I wanted to get my Twitter username, which you can add your Twitter username to your GitHub profile, you can just get that as well. Also gives you the node ID, which is the one that we can use for the GraphQL API. And this ID is just a unique identifier on the database on GitHub. Many times people decide, oh, what should I use? Should I use that ID or the other? This is good for databases, but I find that one that allows you to do more directly with the API is worth storing. So if I want to get information about this user, say Nostrican, I can just go ahead and use this one here. I don't have to go and search for a user that's cool, that has that login, and then look the information up. I can directly say, I want information about this user in particular. And it's just nice for the API that you're helping them out finding the information faster in a cheaper way. So now we're going to get information about repos. So here I have the base URL, the user endpoint, and because I'm just passing the user endpoint, it's going to default to the login user. Then I'm gonna look at the repos, and the default per the documentation is basically every repo that I'm a member of. I'm passing the per page should be 100, and I'm going to get the first page now. So I'm gonna run that. Right. So as you can see, my rate limit has decreased because I have been using the API. And here is all from the documentation. This is the way that you can get how many pages you have to crawl to get all the results using this endpoint. So that means that right now I'm getting the first 100 items, but there are many more. In this case, I know that the next page that I need to get is the same thing, but with page 2. But the last one is page 3. So I know there are 200 and something up to like 300 repos that I'm a member of. Yeah, as I mentioned, this is what gives you the scope of the authentication. This here starts with a bracket, and then, the curly bracket. This means that this is a JSON vector, and each of those are JSON elements. So what this is giving me back can, for example, get the length of the vectors. Some of you might suspect it's 100. So I have 100 JSON objects in that vector. I'm gonna look at the first element in that vector. So the first repo that I return. And I get something like this, where it has an ID, a node ID, a name. So this DSPG American Soldier, the full name, which has the owner first, whether it's private or not, information about the owner. So this would be information about the organization, information like the description of the repo, whether it's a fork, the URL to get to that repo, fork URL to get all the forks from that repository, to get the link of every collaborator for that one, etc. A lot of information here. Commits, SSH URL, so you can, like, if you wanted to clone the repo and get that information directly, all the way here. And you can also get whether my permissions for that repo. So in that repo, I am admin, I can push, I can pull, and the default branch for that repository is master. And I didn't find any license. Does that make sense? Is this cool? Seem nice, useful? See, you can put something in the chat, so I know that people are paying attention. Seems useful. Well, just in case, we're gonna do the same thing, but now we're going to get the second page. So I'm gonna do the per page here. Per page, the same information, just that we're changing that that argument in the URL. Now we can get, I'm just gonna override information. And if I do the first one, let's see what we get. Try to do the right one. Oh, repos continue here. Repos continue. Sorry. So this one is Nosfreaken UEM repo. So that's a different repo that's not one of the first 100 that I returned. Is this useful? Do you feel confident enough to give it a try, to do some exercises, basically on how to read the documentation, basically, and then figure out? What I might do is give you a homework of getting some information about GitHub, and then you can just write back the answers to those questions. Okay, so REST APIs are great. Oh, let me just do the one for rate limit. So this is one that I use quite often, the free requests. So here what I'm doing is I'm hitting the rate limit endpoint. And when I do that, I get this here. This is the information given by the API. This is a JSON file, so I can just read that. Oh, actually, yeah. And this one here has some elements or attributes. So when you want like further the question of whether you should be using a given language or an API or what tools, if I just had the response, I might get something like, let's do this one here. That only gives me a number, but I can use Julia, for example, to convert from Unix timestamp to a date time. So I know that's the date time there, but I want to keep everything in terms of the same time zone, which is UTC. So I can then convert that into the zone time zone timestamp that I care about. And then when I upload that to the database, for example, I will convert that into a Postgres timestamp, no time zone, or without a time zone, because I know everything is in UTC. So a lot of it is just handling the messy JSON formats that you might get and making sure that you get a suitable interpretation or representation that then you can work with, let's say for a table, or dividing data into different tables. And that's a whole data architecture. Many hours go into getting that, especially for one of my projects, we get Twitter data. So Twitter data, if you look at the API, it has the object, information about the user, then a bunch of other stuff, and then it might have a parent object. When you have like a retweet, then you have the same information, but for a different object or a tweet object. So you just need to come up with a way of getting all that messy JSON into something that you can actually work with. So what I want to show you next here is, let's go over here, the GraphQL API, which I am very much a fan. So a GraphQL API, to mention all its specification based on a schema, is strongly typed, so you know exactly what you're gonna get in terms of types. And it's hierarchical, so you can crawl down if you need to. And it works really well for objects and lists or vectors. And instead of having all those verbs like get, post, delete, put, it only has two operations, queries or mutations. Queries don't change data in the server, mutations do, that's it. Okay. Let's see. Queries to explore. Just log in here. And I will show you, see if the schema actually loads. This is not gonna load. Oh, GitHub, don't do this to me. All right, so docs, there we go, it worked. Can you all see my screen right now? I'm just making sure everything's good. Yes, okay, perfect. So this is a nice tool for playing around with the GraphQL API. And there are similar tools for REST APIs, like Swarm, I forgot what the name is, but it's kind of neat. But I like the GraphQL more, so I'll go over this one. So, oh wait, there we go. No, there we go. So this is a query. For this query, I'm going to look at a user. If GitHub doesn't make me sad. Okay, there we go. So I can get a user, and it just takes a login. That login, I'm gonna call it not free again. Then I can crawl the user. So I can say, I want to get the ID of the user. I also want to get, let's say, my Twitter username. Let's just do that. So what happened here is, remembering the REST API, that would give me a lot of information. If I just want to get those two fields, I just want to get the Twitter username, I can do that without having to transfer all the information that I don't care about. So that's more efficient. I can also say, I have which repositories I have contributed to. Get the page info and get and cursor and see what's the count should be up. Total count. let's do made it too small, right? Let's see if I can make that a little bigger. Is that good? Okay. So for example here, what I have done is I first look for a username. I can get some information about that user, but then I can query things that are related to that entity. So I can say, what are the repositories contributed to, or basically by that user? And then I can get a count of how many repositories there are. And I can paginate by using the same strategies that we had before. So what I'm gonna do is I'm gonna call the edges. And for each node, I'm gonna get the name with the owner. So now I have that information here. And I can go from what's the user. I get the ID is if I need to query it again. I can get information about the user. I can get information related to that user from a different data camp or data hub, which for in the REST API, I would have to use a different one. I would have to use the user endpoint to get this information, and then use a different endpoint to get the information about the repos that I have contributed to. And then I would have to get a different endpoint to get the information about those repos. So I would have had to use at least 3 different endpoints and a bunch of calls. But with the GraphQL API, I can just do that directly. And if I want to get information about that repo, I can do that as well. Say on repository and say I want to get default branch for that. Okay. Or actually, I want to get the name. And well, I won't do too much, but let's just do that one. So now what I'm doing is going from user to the repositories that that user has contributed to then getting a vector of repositories. Then from those repositories, get information about the default branch. So here I'm crawling a bunch of different endpoints in the same query. Okay. And I can do the same thing. Say so I'm going to create a fragment. And this fragment is going to be cool. And it's going to operate on a user. On user, there we go. So I'm going to take all of this. Put it here. I think that should be good. One or two. Let's see how this goes. Unexpected end of document. Refund. Probably missing one of those. Nope. That looks good. That one? No, that's still missing something here. Oh yeah, that looks better. Okay, well, let me just get an old one because somehow I messed that up. Okay, so let's do that here. I'll just show fragments in a little bit. The other thing that we can do is have the same query, but pass different parameters. So here, what I'm saying is this query takes these parameters or these arguments, takes an owner one, which is a string that you cannot omit, takes a name, which is a string that you cannot omit, and then you can pass the arguments by query variables. So here I'm going to say the owner will be Nostrican, name one will be colorimetrics, owner two will be, I just know, well, let's do Julia Lang. Name two will be so what happened here is the server will get the query, but after it has the queries, it will look and replace that information here with the query variables that you're providing. And this is just a JSON object that you pass as the data. Does that make sense? Yes. Another way that you can, or another thing that you can do is, I think when that happened, just save that here. That's an issue that I reported to GitHub, so hopefully it gets fixed soon. So I can make a fragment. Fragment, let's say, call it magic, no, foo. On, this is a repository. And we'll just have that. There. I think that should work. Value not to null. Oh yeah, let me just copy this again. There we go. So you can also use fragments, and fragments are basically you don't have to repeat yourself. So you can pass, basically, let's say that I want to get some information about the user. So I can just pass a user and apply it like a function, basically, where I say, I want to get all these data for that user or that repository. Does that make sense? Let's see. People are not confused by fragments. Maybe they are, not sure. So fragments basically just copy paste all the code that you have in the fragment here before resolving the logic in the server side. Another cool thing is that you can pass or make different queries per se. So I can query things about the repository or about a repository and then about a user in the same query. So in the REST API, those would have to be different queries. In the GraphQL, I can put a bunch of different queries all in the same transaction. So that saves you a lot of time and it costs you less, right? One issue with that is sometimes if you ask for too much data, it will crash, and there isn't a good way to assess that other than trial and error. So if I were to ask 1,000 of these, it might crash. If I do 500, it might be good. So because when I started, for example, I would just do one at a time. But then I figure out and got familiar with GraphQL and say, oh, wait, I can actually query 500 of those repositories in the same query. So that's a lot faster. And I don't have to spend, or I can make more queries in the same hour. So that's really nice. The problem is, depending on what kind of data you're getting, it might crash and say, oh, timeout. So you have to adjust how much data you're asking depending on the API and how it's feeling that day. So you just have to trial and error. So it's kind of like playing with the API. Why done? Let's see, how are we doing on time? Let's see. Okay, so we have 14 minutes. So why don't we? I want to hear some questions first, and I'll give you something to practice. Let's see. This is where we're going to practice for now. Any questions? I've been super quiet. No, no questions at all. Okay, I'm going to ask you all to do something. How do you 500 at the same time? So here I'm doing green. If I wanted to do more, I would just make a different one. Then log in, say not green again, get my Twitter username. That's how you would make like more queries in the same one. Let's see. So sometimes you can pass the variable names. So here, if I wanted to do 100 repositories, let's say, I would pass 200 variables. That's fine. Sometimes you cannot use the environmental variables because something here changes. And that's the case, for example, to get repositories. So here I'm just going to make a different example. I'm going to I'm going to do a search. My query is going to be, let's see, I want license has to be MIT. Type what I'm supposed to get is a repository, but I want MIT. Okay, yeah. And let's do repository count. So here I'm just looking at, actually, I'm just going to do this private false. No, public. I always get confused with these. Nope, let me just look at that. Because I have the code somewhere. Let's take a look. So, I have not pushed my changes yet. Okay, well, I have it here somewhere, so we can figure that out. Let's do search syntax GitHub API. Oh, wait, not this one here. Public or private, let's see. Nope, okay. Actually, I can get it from here. So if you go to GitHub and you want to look for something, you can say, want to find private false. What I want to do is go to advanced search. I'll delete that. And let's do, let's see, public. No one see these? Okay, let's just do this. I want to get MIT licenses. Here we go. That use the R language. So that's the query there. And it's showing me 16,000. So there are 16,614 repositories. that met that criteria. So I'm just going to copy that here. Go to my Explorer. And this one here, if you see a little thing over here, it said, oh, actually it's an approximation because it took too long to finish, so some of the results may not be shown. So this is actually not correct. So if we use the API, here, we get the actual number of repositories that made that or that have that criteria. But we might want to do created to between, or let's say last year. Or yeah. So there were 4,500 that were created last year. And I know they were created last year because I'm filtering the query by when the repository was created. So I cannot by any means get all the repositories that are licensed MIT, let's say. There are too many, and I'm the limit of it's 100 per page, right? By search connection, and I can paginate up to 10 pages. So that means that I have to break up that query into queries that give me up to 1,000 results. So part of the library that I have been developing over the last year or so is doing that. So for every license in GitHub, I come up with different time intervals. For some licenses, it might be a month. Sometimes it's an hour. Came up really creative way of basically querying every day and then parsing those out. Just answer the question of how can I get all the results from this query in a way that I can actually get the information. And it's not a trivial issue. So why don't you all go to the link, and I want you to give me the first. So here I'm gonna do edges, node, repository, say owner with name. Right. Oh, I need to pass that over here. So this one here is the name with owner. That's actually code server, and I have a bunch of those. And those are repositories that I can see that have an MIT license and were created at that time point. So what I want you all to do is, it's gonna be a little competition in the next 5 minutes or so. Go to the Explorer and give me the ID, the global node ID for the first or the oldest ever repository in GitHub. Okay? Does that make sense? Let me see participants. Do you all agree? Here is the search query to understand how to do that. And in 4 minutes, I'm going to give the answer. So I want you all to try it. We have the links. What I want you all to provide is to say the global node ID of the first ever created available repository in GitHub. Okay, does that sound good? Gonna give you all 4 minutes to do that. I'll leave my code here in case you all want to see it. If you have the answer, you can put it in the chat. We'll see how many of y'all get the right answer. So you would have to modify this query in order to get the first ever repository in GitHub. This will stay the same. The repository count should be fewer than 1,000, right? Because otherwise you probably are not doing the right query here. And you should modify this part here in order to get the global ID. Okay. Aaron, do you have anything to say or to add? Hints, anything?
Not really, other than I was going to mention that in the data camp class that I signed yesterday on web development and R, its whole first chapter is on working with APIs. So that will review, or to work with probably about the first half of what Bayoán was talking about today. But the GraphQL stuff is different on your own and new and cutting edge.
Yes, if you can use it, it will make your life 100 times better. So we're teaching it, but most APIs are by far REST. So they're quite simple. You just pass everything in there, but it's just practicing.
And we will be updating the training repo with stuff from today.
Okay, anyone? Last 20 seconds? No? All right, I'll give the answer then. So we don't care about the license, so you can get rid of that. For created, we want to make sure that it starts or before some date. So let's just try to do, say, 2010. And let's see what we get here. And we want to actually get the ID as well. And let's see what we have here. So it says that there are way too many repositories yet. So let's do that 2009. Too many yet. So let's do 2008. There's only one that was before 2008. And it's this repository. And that's a global ID. So now you know this repository is the first ever accessible repository, or the oldest created repository available on GitHub. It's Mojumbo Grid, and it's, let's just show here. It's this one here. Okay, it's UR, and it's no longer maintained. It was a Ruby development one. All right, that's what I have for today. If there are no questions, have a great day then. Thanks.
All right, terrific. Thanks, Bayoán.